Hi, this video is on graphing rational functions. This is the first part of the two videos that I'm going to make. A rational function, we define it as the quotient of two polynomials. It is one of the most challenging topics because of so many different things that are involved. You can see from this list that it gives you the procedure that we follow, how much is involved. So I'm going to briefly go over that. So what we do is we factor the numerator and denominator if possible. We never simplify at this point. We're going to find any real values that make the denominator 0. Those will be your excluded values for the domain. And we're going to be able to state the domain. Then we're going to check each excluded value in the numerator. If the numerator is also 0, then we're going to have a hole. If the numerator is not 0, then we have a vertical asymptote. Then we're going to simplify our function after that. And we're going to continue with the simplified function from that point. We're going to set the numerator equal to 0 to find any x-intercepts. We set x equal to 0 to find the y-intercept. Then we're going to substitute the x-coordinate of any holes that we have to find the y-coordinates. Then we're going to find the horizontal asymptote. I will get to that once we start doing problems. There are different cases. Then we're going to sketch all asymptotes that we may have. Finally, we make a table of values with different points here and there to make sure that we have at least 3 points for each interval, because we need to capture the intervals between asymptotes and or holes. And then we'll finally plot the points and connect them. We need to make sure when you draw the branches, they cannot cross vertical asymptotes and do not go through holes. So let's take a look at the first example. We got this function f of x equals 2 over x minus 1. So we're going to follow our procedure. Our first step is going to be to set the denominator equal to 0. And that's going to give us x equals 1. So the domain is going to be all real numbers except negative 1. So x cannot equal, 1. X cannot equal 1. Okay, we can't do any factoring here. It's a relatively easy problem. So what we can do after this is this value is going to make the denominator 0, but the numerator is a constant, so we're going to have a vertical asymptote at x asymptote. Its equation is going to be x equals 1. So what I want to do right away is I want to sketch my vertical asymptote at x equals 1. Okay. Continuing on, we can simplify our function, so we're going to continue with this. So how do we find we can find the y-intercept? Well, we can set the numerator equal to 0 to find the x-intercepts, but the numerator does not equal 0, so we have no x-intercept. Then we're going to set x equals 0. So when x equals 0, we're going to get y equals, so it's going to be negative 2. So our y-intercept is going to be 0, negative 2. Okay, and that's pretty much all the prep work for this one. This one's relatively easy. What we're going to need to do now is a table of values. So with the table of values, we are going to pick some numbers for x. Since we have a vertical asymptote at 1, we're going to pick 3 values on one side of negative 1, positive 1, and the 3 values on the other side of 1. So x, y, we're going to have 1 here, for which the function is undefined. We're going to do 0, negative 1, negative 2, and here we're going to do 2, 3, 4. I'm not really going to guide you through each computation here. I'm just going to put the values. So for all these values, we are going to get the following numbers. For negative 2, we're going to get negative half. For negative 1, it's going to be negative 1. For 0, we know it's negative 2. For 2, it's 2. For 3, it's 1. And for 4, it's going to be a half. So what we're going to do now is we're going to plot those points. Oh, we do have a horizontal asymptote, I forgot to mention. There is a horizontal asymptote here. and I will explain how we figure it out. So the degree on top is 0, we don't have x. The degree on the bottom is 1. The degree on top is less than the degree on the bottom. Automatically the horizontal asymptote is going to be y equals 0, which is the x-axis. So we're going to sketch that too. We really don't have to, but it helps us guide our branches, so we're going to do that. And now let's plot the points. I'm going to use a pencil for that because I want to make it nice and neat. So let's start here. 4, 1/2. So 1, 2, 3, 4, 1/2. 3, 1. 2, 2. So over here we're going to have a branch that's going to look like this. Okay. And on the other side of 1, we're going to get 0, -2, -1, -1, and -2, -1/2. So this branch is going to go like that. So a couple things that I want to make emphasis on here. Both branches are going to start approaching horizontal asymptote closer and closer as we get farther and farther away from the origin. Over here, this branch is going to approach the vertical asymptote going up, and this branch is going to approach the vertical asymptote going down. So this is our graph. All right. Let's take a look at this one. A slightly different problem. It does say to factor, so let's see if we can factor this function. We can factor out 2. That doesn't do a whole lot, but we still do it. After that, we're going to find any values that make the denominator 0. So our denominator is x plus 1, which means x is going to equal -1. That means our domain is going to be any number except -1. We cannot use -1. So now the question is, what do we have at -1? Is it going to be a vertical asymptote or a hole? So if I take -1 and I plug it in the numerator, I'm not going to get 0. That means this is a vertical asymptote. Okay, and the vertical asymptote is going to be x equals -1. We are going to sketch it right now. Okay. What about the horizontal asymptote? Well, the next step is to simplify. We can't simplify that, so we're just going to leave it like that. It tells us in the next step to set the numerator equal to 0. So if I set the numerator equal to 0, I'm going to get x equals 2. This is my x-intercept, 2, 0. After that, I'm going to set x equals 0. So when x is 0, I'm going to get y equals -4. So 0, -4 is my y-intercept. Now we're going to take a look at the, we don't have any holes here, so we don't have to worry about that. What about horizontal asymptote? The degree on top is 1, the degree on the bottom is 1. They are equal. In this case, the equation of a horizontal asymptote is going to be the ratio of the leading coefficients, so it's y equals 2 over 1, or simply y equals 2. So we have a horizontal asymptote here that's going to be y equals 2. Let's sketch that. Okay. Our next thing to do is make a table of values. So we only have one value we have to worry about, which is -1. So I'm going to use a table with the values, and I'm going to put -1 in the middle. So -1 goes here, I'm going to have 0, 1, 2, and here we're going to have -2, -3, -4. Again, I'm not going through computations, you just substitute each value into the function and do the math. So what I'm going to get here the values that will be 4, 5, 8, undefined here. This one's going to be -4, -1, and 0. So we can plot those points now. So -4, 4, 1, 2, 3, 4, 4. -3, 5. -2, 8. 2, 4, 6, 8. Nope, that's not 8. Yeah, it is 8. On the other side we have 0, -4. 0, -4. 1, -1. 2, 0. We also have we already got both our intercepts plotted, so we're good. So what's going to happen here, this graph here is going to, this branch here is going to approach the asymptote on the way down. Over here we're connecting that, it's going to have to turn and approach the horizontal asymptote. And over here, very similar type of behavior. And there is our graph. Okay, moving on. So now we have this equation. So our first task is to factor. So 3 times x plus 3 divided by x minus 3 times x plus 3. So we set the denominator equal to 0. That's x minus 3 times x plus 3 equals 0. It's going to give us x equals plus or minus 3. That gives us 2 points. They're both excluded values. So for the domain, we're going to say that x cannot equal plus or minus 3. But that's domain. Now we have to determine what's going to happen at each point. So when x equals 3, what do we have in the numerator? When x is 3, the numerator is not going to equal 0. We don't care what that number is as long as it's not 0. So at x equals 3, this is a vertical asymptote. What about x equals -3? Well, when x equals -3, the denominator is 0 and the numerator is going to be 0 as well. So this is where the function is going to have a hole. So what we're going to do now is we're going to simplify it. Once we simplify it, it becomes 3 over x minus 3. The x plus 3 and x plus 3 are going to cancel. And from here on, we are going to use our simplified equation. Okay? So our next step will be to set the numerator equal to 0 to find any x-intercept. The numerator cannot be set equal 0, so you have no x-intercepts. To find the y-intercept, we're going to set the denominator x equals 0. So when you set x equal to 0, you're going to get y equals -1, and that's going to give us 0, -1. This is our y-intercept. Now we need to find the coordinate of the hole. So the hole, we know its x coordinate is going to be at -3. To find its y coordinate, we're going to take this value and substitute it in here. So it's going to give us 3 over -6, which is going to give us -1/2. There's a hole at that, and we're going to plot that hole on our graph. Okay. This graph has a horizontal asymptote, this function. You're going to go by comparing degrees. The degree on top was 1, the degree on the bottom is 2. So the degree on the bottom is higher. The horizontal asymptote will be y equals 0, which is the x-axis. So let's plot all this. So we have one vertical asymptote, x equals 3. We have a horizontal asymptote, which is the x-axis. We also have a hole at -3, -1/2. So -3, -1/2. Over here we have a hole. We're going to put an open circle there. Okay. Now we need a table of values. So for a table of values, we're going to have to skip two numbers. Our table of values is going to be longer. So we're going to go with -5, -4, -3, -2, 0, 2, 3, 4, and 5. Okay. We know both at -3 and 3 the function is undefined because you cannot divide by 0. And what we're going to do now is write the other value. So this value is going to be -3/8. This value is going to be -3/7. This value is going to be -3/5. This one's -1. This one's -3. This one is 3. And this one is 3/2. So when we plot, it's easier to work with decimals. This is approximately -0.38. This value is approximately -0.43. This value is going to be roughly -0.6. And this is about 1.5. So we're going to plot these points. So -5, -3/8. It's kind of hard to do it precisely. Somewhere over here, -0.38, -0.43. This point at -2 we have 0.6. So it's going to slowly start turning this way. At 0 we have -1. At 2 we have -3. -3. So you can see how it's beginning to turn here. On this side we have at 4 we have 3. And at 5 we have 3/2, which is 1.5. So I think we have enough. Over here we're going to go like that. But this is what I meant. Do not go through the holes. And here we're going to connect it like this. Please remember that these graphs are supposed to be smooth curves, all the branches. There shouldn't be any sharp turns here, and they have to go through all the points. And please note that over here I have an open circle to represent the hole. Alright, next one. So we have this function, and we are going to try to factor it. The numerator does factor x minus 4 times x minus 1. The denominator is already in factored form. So what we have here, we know the denominator cannot equal 0, so we're going to set it equals 0. X equals 2 is our excluded value, which means for our domain, x cannot equal 2. So we're going to exclude that value. Since when x is 2, the numerator is not going to equal 0, we know it's going to be vertical asymptote. So x equals 2 is a vertical asymptote. Okay. So our next step is to take this as we're going to set the numerator equal to 0. So x minus 4 times x minus 1 equals 0. That's going to give us two values, 4 and 1. Those are our x-intercepts. So our x-intercepts are going to be 4, 0 and 1, 0. To find the y-intercept, you're going to set x equals 0, and we are going to get 0, 1. All we do is substitute 0 into the function, we get that. Okay, our next thing is we're going to see, we don't have any holes, so we don't have to worry about that. Horizontal asymptotes. The degree on top is 2, the degree on the bottom is 2. It's going to be the ratio of leading coefficients. So horizontal asymptote is going to be the coefficient on top is 1, the coefficient on the bottom is also going to be 1, so it's going to be y equals 1 over 1, or simply y equals 1. And now we're going to make our table of values. So we only have one value that we're skipping, which is 2. So we're going to have to make it as large as the previous one. We're going to use these values, -1, 0, 1, 2, and then we're going to have 3, and 4, and 5. Okay. So we're going to substitute these values. This is going to be 10 nines. This is going to be 1. This is going to be 0. This is going to be undefined at 2. At this point we have -2, and then we have 0, and then we have 4 over 9. 10 over 9 is approximately 1.1. 4 over 9 is approximately 0.4. So now we should be ready to plot all this. Let's sketch our asymptote. So the vertical asymptote is at x equals 2. Horizontal asymptote is y equals 1. We can plot some of our points. We have our x-intercepts at 4, 0, and 1, 0. So 4, 0, and 1, 0. We have our other points. Let's see, at 3 we have -2. At 5 we have 0.4. So 2, 5, about 0.4. So this branch here is going to go like that. On the other side we have 0, 1, 0, we already got that, 0, 1, and then this is 1, 1, 0, 0, 1, and then 10, -1 is going to be 10 nines, so 10 nines approximately 1 point something, right? 1.1, so at -1 it's 1.1, and then over here we're going to have 0, 1. So we have a situation when the graph is going to cross its horizontal asymptote, which happens. It cannot cross its vertical asymptote, but horizontal it can. And there is the graph. Okay. Moving on. This problem here, we have this equation. So we have some factoring that we need to do in this problem. So it's going to be x minus 2 times x plus 2 divided by x minus 3 times x plus 2. So what's going to happen here is we are going to set the denominator equal to 0. And that's going to give us our excluded values. So x equals 3 and -2. So our domain is going to be x cannot equal 3 or -2. These are excluded values. So what we need to do next is we are going to see what's going to happen at each point. So when x equals 3, we have 0 on the bottom, not 0 on top. When you plug in 0 in the numerator, I'm sorry, when you plug in 3 in the numerator, you do not get 0. So this is a vertical asymptote. Okay. When you substitute -2, you're going to get 0 here and 0 here. This is 0 divided by 0. This is a whole. And after that we can simplify our function, which gives us x minus 2 divided by x minus 3. And we're going to go with this simplified form. Okay. So next thing we want to do is we want to find our y-intercept. So we're going to set x minus 2 equals 0, which gives us 2. So 2, 0 is going to be our x-intercept. We set x equals 0, we're going to get 2/3. So 0, 2/3 is our y-intercept. All right. Now we do have a hole here, so we want to evaluate the function at the hole. So we're going to plug in x equals -2, and at that point -2 is going to give us 4/5. Remember, this is our hole, so we actually are going to leave it open. A table of values. Remember, there are two values we have to skip, so it's going to be a little longer than the one before that. So what we're going to do here is we're going to make a table, and these are the numbers we're going to use: -4, -3, -2, -1, 0, and then 2, 3, 4, and 5. So for each one of them, we're going to figure out the value of the function at these points. So at -4, it's -6/7. -3, it's 5/6. At -2, it's undefined. At -1, we get 3/4. At 0, we get 2/3. At 2, we have 0. At 3, we have undefined. At 4, we have 2, and here we're going to have 3/2. So this is approximately, this is -0.8. This is 0.8. I'm sorry, this is positive. So it's positive 0.8. This is about 0.8, also very close. Over here we're going to have 0.75. Here we're going to have 0.67. And here we're going to have 1.5. Let's get your asymptotes. So x equals 3 is our vertical asymptote. Y equals, I'm sorry, I did not do the horizontal asymptote. I kind of got ahead of myself. A horizontal asymptote will be, let me write, I didn't do it, right? So for a horizontal asymptote, the degree on top and degree on the bottom are the same, so we're going to divide the leading coefficient 1/1, so it's y equals 1. See how much there is to remember here? I forgot about some of it. It's okay. We'll get to it eventually. So y equals 1 is here. Alright. And now it's time to plot the points. So this is about 0.8. At -4, 1, 2, 3, 4. About here. This one's going to be relatively close. We're going to have a hole at -2 at 4/5. At -1 we have 0.75. Right, it's 0.75. And at 0 we have so it just keeps going like this, going like that. At 2 we have 0. Okay. And then at 3 it's undefined, and over here we're going to have, at 4 it's going to be 2, and at 5 it's going to be 1.5. So that is our graph. So over here it's going to go like that, and then we're going to go around and hit this. It's supposed to be a little smoother, and over here it's going to go like that and like this. Okay. Now please note there is a hole at -2. Alright, moving on. Let's take a look at our next problem. So we have this equation. This is our function. The factoring here is in the numerator is not going to work. This is not a factorable expression, but the denominator can be factored. So it's going to be x minus 2, and I'm sorry, x minus 2 times x plus 1. Let me rewrite that. X minus 2 times x plus 1. I'm sorry. Okay, so we have two values here that are going to be excluded values. So x minus 2 times x plus 1 equals 0 means x is going to equal 2 and negative 1. So our excluded values, so the domain is going to be x cannot equal 2 or negative 1, right? So we are going to exclude them, and for both of these values the numerator is not going to equal 0, the numerator cannot equal 0, so these are both vertical asymptotes. Right, so it's going to be x equals 2 and x equals negative 1. Alright, so there is no value that's going to make the numerator equal 0, therefore we have no x-intercept. When you make x equal 0, we're going to get 0, negative 1/2, so that's our y-intercept. We have no holes here because there is no 0 divided by 0. And for the horizontal asymptote, we're going to have the same degree, 1 over 1. So we divide the leading coefficient, y equals 3 divided by 1. That's going to give you y equals 3. I think we got it all. So let's go ahead and make a table of values. So our table of values, right here, x, y, we're going to do negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Okay. So at negative 1 and at 2 the function is undefined. Oops, let me use the same color that I've used before. And then we are going to calculate the other values. So over here we have 49/18. Here we have 14/5. Here we're going to have, it's going to be about 3.25. I forgot what the decimal is. Here. At 0 it's going to be negative 1/2. At 1 it's going to be negative 2. At 3 it's going to be 7. And at 4 it's going to be about 4.9. I don't have a decimal here, but that's going to be good enough. So let's go ahead and graph our asymptotes. So we have two vertical asymptotes here. We have not seen this yet. We have one at 2 and one at negative 1. We have a horizontal asymptote at 3. Okay. So let's plot the points. What do we have here? 49/18 is about 2.7. So at negative 4, about 2.7. At negative 3, we have, that's about 2.8, roughly. Well, they're very hard to distinguish. Over here, we are going to have, at negative 2, we're going to have 3.25. 2, we have 3.25. And at negative 1 it's undefined. So we have a situation when the graph is going to cross like this part, and go like that. So undefined at negative 1. At 0 we have negative 1/2. At 1 we have negative 2. Here we have 7. At 3 we have 7, 3, 6, 7, and 4 we have 4.9. So this is pretty simple too. But here we have a little bit of a question. What happens here? So this side's gonna drop, But what happens here? Does it go up or down? Well, we're going to need another point. We're going to have to pick a point close to the vertical asymptote at -1. So if I use -1/2 and I substitute -1/2 into my x, my y value is going to become -7/5. So that's about -1.4. So it's going to go lower, and this side's going to be here. So then this is going to go like that. Okay. All right, we're almost done. We got one last one to do. So here we are going to factor it first. So we have 2 times x squared minus 8, or I'm sorry, minus 4, divided by x squared plus 1, which is going to be 2 times x minus 2 times x plus 2, divided by x squared plus 1. The domain here is going to be all real numbers. There's no value that's going to make the denominator equal 0. So we don't have any vertical asymptotes, obviously, or holes. Okay, so what do we have here? We're going to have our, to find our x-intercept, we set the numerator equal to 0. So x-intercepts are going to be 2, 0 and -2, 0. For our y-intercept, we set the numerator equal to 0, and that's going to give us 0, -8. Okay. As far as a horizontal asymptote, we have one. There is the degree on the top and the bottom is the same. So the horizontal asymptote will be the ratio of the leading coefficient 2/1, which is 2. Okay. So we're going to graph the horizontal asymptote, y equals 2. And we're going to make a table of values. So we're going to need to pick some points. Enough to do that, since we do not have vertical we don't have vertical asymptotes here. So what we usually do is just pick enough points just so we can get an idea what the graph is going to look like. So in -3, -2, -1, 0, 1, 2, 3. Our values will be 1, 0, -3, -8, -3, 0, and 1. So I'm going to plot these points. -3, -1, -2, 0, -1, -3, 0, -8, and then it's going to go back up through the same values. Okay, so what's going to happen here is the graph is going to go like this. It's going to take a dip, turn around, go back up, and approach the horizontal asymptote again, and that's it. I hope this was helpful.